stars we are seeing in the past, but have you ever wondered why?
In the first decades of the 20th century, Albert Einstein showed with the world his special and general theory of relativity by restructuring the way we understand space, time, and gravity. In 1905, he explained that time and space are not absolute and independent of one another, but they actually merge in a constant four-dimensional dynamic known as space-time, which can bend as if it was an elastic band. Later on, in 1916, he included gravity into his theory, explaining that gravity was the result of the space-time curvature. His theory was contradictory to Newton's laws, since they took for granted that they were absolute, like a chessboard in which the universe played its games. This change of perspective led to suggest the concepts of the Big Bang theory and the existence of black holes.
Now, getting back to the stars, Einstein described light as a constant speed, traveling 186,000 miles per second, no matter how fast the observer or light-emitting object is moving.
Matter and energy are interchangeable, showing the famous equation E equals mc squared. Since the speed of light is a huge number, even an insignificant amount of mass can be converted to a large amount of energy, just like an atomic bomb.
Gravity, instead of being an invisible force that attracts an object to another one, is the capability of curving the space. So the more massive an object is, the more it curves the space around it.
This explains some of the things scientists know about black holes. As they have a lot of matter and energy concentrated inside them, hence experiencing time dilation, the greater a gravitational field is, the slower time will pass compared to an observer in another gravitational field.
So if you travel somewhere near a black hole and go back to Earth after a year, for your family and friends, it would have passed decades or even hundreds of years, just like in Interstellar.